So moving into algebra, what we're going to do is look at a question like this, but really just isolate it first. I just want to ask the question, how many x's are there? And so if we look at the top, we can see that there's negative 3x's and then 3 of them. And so just looking at the x's, there's x to the power negative 3 times 3, x to the power 3 here twice. So we can say x to the power negative 3 times 3 times is x to the power negative 9. And x to the power 3 twice is x to the 6. Now we can use our exponent laws. X to the negative 9 minus 6 would be negative 15. We can also move the x to the negative 9 down. This is going to be a new strategy that we're allowed to use. And so if we said that it's x to the negative 15, what that really is you can say x to the negative 15, but that's actually 15 x's in the bottom. So what we can do is take the x to the negative 9 and slide it down, and then combine it with the 6 x's in the bottom. And so we have 15 x's in the bottom. So kind of looking at it all together, so this is this is a question that we'll do all together. But if you look at the 2 and the x's and the y's, we're really looking at them separately. But a strategy that you can use, I call the down slide. It's this playful name that I kind of used, but I found this strategy very helpful. Since we know that x to the negative a is 1 over x to the a, and 1 over x to the negative a is actually x to the a. It's a similar idea, like we can flip and multiply. When we have a numerator and denominator with multiple factors raised to exponents, which is what we have here, so we've got 2, an x, a y, and an x and a y, all raised to exponents. Any exponent that is negative, so this negative 3 and this negative 4, can be slid up or down to become positive. One warning here is we can't slide anything that doesn't. So you can't slide the 2 down. You can't slide the y squared down. You're going to leave the x cubed there. We only slide the things that we can, that are negative. So this x to the negative 3 slides down to become with the other one. And the y to the negative 4 slides up to go with the y squared. So those are the two things that changed. What that does is it really just helps us kind of count without worrying about the negative signs. So now we've got 6 y's on the top, and we've got 6 x's on the bottom, and we can see it. And that's actually done. Now they're combined together. If some were on the top, some y's were on the top, some y's were on the bottom, they could cancel out. Same with the x's. Similar to what we did in rational expressions. And that's really what we're getting to. But the 2, the x, and the y, they're all separate. This is the example that we saw. We knew there's 15 x's in the bottom here from the previous question. So I just want to kind of point out, though, the fact that 2x to the negative 3 y squared to the 3 is actually that 3 times, and the bottom is that twice. And so that's a good thing to know, because what we're actually going to do is we're going to bring that 3 in. So you don't have to write this out, but we're going to bring this 3 in to the 2, the negative 3, and the 2, so that we can see that 2 is multiplied by itself 3 times. The x to the negative 3 is multiplied by itself 3 times, and the y squared is multiplied by itself 3 times. Similarly, the x cubed twice and the y to the negative 4 twice. So we actually end up with 8x to the negative 9, y 6, and x to the 6, y to the negative 8. Doing that slide, we can slide the x to the negative 9 down, the y to the negative 8 up. Notice that 8, y to the 6, and x to the 6 do not slide. They do not have negative exponents. And then we can combine like terms. We got 14 y's and 15 x's. Okay, and some practice.